Aaron, I thought the easiest way for me to convey this was to do a video so you can come back to it if you need to. And I think this video is going to take about 45 minutes. And I may or may not have actually gotten through this once already, but I'm kind of practicing my recording skills. But I'm also doing this completely off the cuff with about 4 lines of notes for 45 minutes. So we've got some stuff to go through. First thing I want to cover real quickly is my environment. Just so you know, I'm still running on my Mac, as you can see. I'm going to shrink my screen size in the second segment of this, but I want you to understand that I'm running on a Mac. I'm using a virtual machine that's actually in the cloud. I don't even think I still have it open. Let's see. I don't believe I do. I think I can still get to the portal without having to relog in. So it's caching my credentials since I haven't closed. So I've got a virtual machine. I've got a few setting up out here. This is part of my subscription, Visual Studio subscription. I get a $150 credit a month. I have a thing called a data science virtual machine. So to show you very quickly what this is, and this might be good for somebody that comes up to you after a session and says, hey, I'm interested in R and I don't know what to do. If they don't have the ability to create this stuff on their own or create it on their own desktop, or maybe you might want to do this as well if you're toying around, you can do a search, and if you'll notice what I did, I went to create me a new virtual machine, and it's going to say, what do you want to search for? I can actually do a data science virtual machine. What that's going to do is it's going to list these types of virtual machines that are available to you using the different operating systems. The one that I chose when I created this was the one for Windows, obviously, because that one comes pre-installed with SQL Server 2016. I'm going to go ahead and close this because I don't need it anymore. It comes pre-installed with SQL Server 2016. Here was my other one. And it also comes installed with R already on it. It has RStudio, Python, and all the tools that go with Python. You'll also notice the icons on the desktop came with the machine, so when you start this thing up for the first time, this is what you see. It's a pre-built machine for exactly what you need. The only thing I've had to do to this data science virtual machine since I got it was to update Windows and to install a later version of R. So with that being said, let's go ahead and get right into, and I'm going to walk you through installing R, installing which version of R, installing RStudio, and why we're not going to be using anything that Microsoft ships with SQL or they shipped on this machine, why it all has to be replaced and updated. But first off, this is one of the queries. This is one that you had actually provided. I had taken it and I got rid of the averages and the aggregates and the group bys and all that and got it down to a pretty basic query to start. This is the first pass. After I show you this, after we get through this little session, you're going to be able to go from this to hopefully something that looks a little more like, let's see if I have one open. I bet I don't. Here. Nope, that one's gone. So we're actually I'm going to show you the end result. So when we're done, you're going to be able to click a button that says knit. And if everything goes well, you'll get something out that looks like this. When we're done today, this is where you'll be. You'll be able to, and we'll even open it in a browser to make it more magical for you. You'll be able to get to the point where you can actually have on the information on this function get formatted string or stored procedure, whatever you want. On the y-axis, we have logical I/O reads. On the bottom, we actually have month and day, and you'll be able to get the information of how many I/Os per day did this particular object have. And then using information like the plan ID is how this thing is colored. So if you needed to go figure out, this thing has a plan ID that looks kind of purplish, well, it's either 19 or 105. I bet we can figure it out pretty quickly. And the size of this particular plot dot would be the duration in milliseconds. And then we can change the y-axis on each of these so we can have logical I/O writes over time, average CPU over time, average max memory over time, using the same information, the plan ID and the duration in milliseconds. Now, there's a little Easter egg here I want to show you, something we'll save for later. You'll notice that the average max memory on this drops below 0. This is something that you're able to do using GGPlot, which is the plotting package that we're going to be using, that can create some interesting results. Here's what the plot really looks like. But I actually put something in there called jitter, and I'll explain this in detail later, to where jitter will actually give you the ability that if plots are laying up or lining up on top of each other, there is a package geometry you can add, or a geometry you can add to the plot to say, move everything around just a little bit. And in the visualization plotting world, it's called jitter. Problem is when you do the jitter, it scatters everything so far and apart that it basically puts things below zero. Here's what the plot really looks like, because this particular query only ever used 0 memory, or it used 128 bytes, which is a far cry from this, but we'll get into detail on that later. So I'm going to stop for a second and resize my windows, and I'll be right back to you. Also, since this is meant to be kind of a private tutorial, and I'll probably share this with some other people besides you, there are lawnmowers in the background, there are barking dogs, I have a desk fan going, and I'm playing music in the background. So I'm breaking all the rules. Paul would weep for me right now if you heard all this. However, I've noticed with this podcaster mic, it all seems to be hiding it really well. All right, so we're going to close these because you don't get to know what all these are yet, because we're not there. So we're going to save those results. I'm going to clear out my history here, and this will all mean something to you in a minute. Since you'll probably only ever be running on Windows, Control L is a magical little command that will clear the console. It doesn't work in Mac, which makes me very sad. We'll save that. All right, so this is kind of where we started. We've got the SQL query up. Awesome. Now, we need to imagine for a moment that I am where you are. So, Microsoft does ship an R GUI. They actually ship an R engine on a machine. And if you go to run, it does exist somewhere out if you do a search, but I can never find it, nor do I care. But if you do an rgui.exe, that's actually where R lives. Now, if you do this on a machine where you've installed just the R engine and or R Studio, but primarily the R engine, and you type in R GUI, you will also get R come up. It's just that Microsoft has actually hacked the R GUI, so it now says Microsoft R Server version 9.0. This is not R Server. This is just the R client. Be clear about that. What's important for you to know is what is the version of R that we are running. And you'll see it at the bottom down here. You'll learn to love the nicknames. I have a lot of fun with them. So this one is running version 3.3.2 Sincere Pumpkin Patch. So I need to get you to the R version that I am on. So I'm going to open R Studio. And my colors are different, but it'll still be just as fine. I'm using 3.4. So first thing first, you actually need an updated R engine. One thing about R that will be a source of interest and annoyance is, much like SQL Server, you can run two versions of R engine on the same machine at the same time. Now, don't worry about SQL being installed on this machine. Don't worry about R Server being installed on this machine. Don't worry about anything Revolution did on this machine. We're not going to be using any of that. And I'll show you why in a few minutes, because the packages that we need don't work with R because Microsoft and Revolution R have stopped shipping updated packages. They've kind of dropped the ball, which means their software is now old enough that we can't use it for very much, unless we're creating models inside of SQL to try and do regressions or something, which most SQL professionals are not going to have to worry about for a long time. So if you typed in R GUI on whatever machine you have, and you have a version anything other than You Stupid Darkness, you're going to have to go and download and install a later version of R. So how do you get there? No. So, and I'm a fan of in private mode, incognito. So how do we get there? So do R download, CRAN. So it's going to take you to the Comprehensive R Network, which, in case you're wondering what CRAN stands for, that's it. So we can actually jump straight to Windows. And we want to download R 3.4.0, which is the same version that I'm running and need. So take a moment to download that, and I don't need that. Take a moment to download that. Pause the video, get it downloaded and get it installed, and then come back to me when you've gotten that part done. So now that hopefully that part is complete, when you run, when you go to your R GUI or R Studio, and actually that's the other thing, I need you to install R Studio before we move any farther also. So to get a way for me to describe R Studio, the best thing I can say is R Studio is the IDE for the R engine. And the R engine is that thing you just downloaded and installed from CRAN. R Studio is a completely separate company. They are a for-profit company. They do support the open source community. But what we need is, and actually you can just do RStudio. Actually, you see it right here, download RStudio. What we need from them is this free version they have out there. It's the RStudio desktop. What that's going to give us is, you'll notice that I'm using R because that's the engine, but you'll see these other nice features that are integrated into the IDE, which is what you really need. It makes life so much easier. It's like the difference in using SQL Server Management Studio while you're using OSQL versus trying to use Management Studio. Well, let me rephrase that. It's the difference in using SQL Server using OSQL and using SQL Server using SMS, or SQL Server Management Studio. So the interface is all the difference. So go download this, RStudio, take the latest version, which is going to be the same version that I have. Desktop, download RStudio desktop. And the one that you're going to get should be the same version of mine, because mine's only a couple of weeks old. So get that installed, get it up and running, and come back to the video. So when you do, you should be able to do a version at this point in RStudio once you have it launched. Your colors will be slightly different. I'll show you how to fix those. But make sure that your R version is 3.4, nickname of your You Stupid Darkness. And it's not going to matter for this, because I think there's the latest version is 1.0.143. I think that's the latest for all of us, because I think at the moment I also have the latest version. So at this point, hopefully you should be ready. A couple housekeeping items to get you started. If you do want to change your colors, you can go to Tools and Options, as you saw, Global Options, Appearance, and then you can change to a nice theme. I'm using Tomorrow Night Bright. The other thing I would have you do is go to Packages, and I'll explain what these are in a few minutes. Make sure you change the crayon mirror to something a little more near you, preferably. If it fails, it will figure it out. I usually keep mine either in Michigan or in Oak Ridge. So hit Change Packages and then hit OK. And now we should be back to this. So you've got R installed. A couple just items so you can figure out. You can work from the console. So we saw that we can do a version. We can also, if we wanted to set, a variable that had some data in it. As you get better with R over the years, my caps lock is on. If you get better with R over time, you'll be able to do a lot more of these. This is going to be a string or a numeric. So we created an object, a numeric. Basically, it's a numeric vector called S. So we can actually. But the thing that's nice about this is how it will show up, and you can actually see what's going on over here. So we're not going to worry too much about that. If you want to clean out your environment variables, just hit yes and move on. Okay, so now we've gotten to the point where we have R installed, we have RStudio installed, we have the correct versions installed. Now the work begins. So you should have received some files from me by now. What we're going to start with is the SP over time. This is just an R script. It's a file that you create. You can actually, if you wanted to create one on your own, you'll go from File, New, and just do R script, and it will open a blank one for you. This is the functional equivalent of a Management Studio file. You should be familiar with that. Things to get us started, you can actually grab Session Info. This will tell you what things you have installed right now. It's not that interesting, but if you need to compare your environment to somebody else's environment, this is what you will do to get there. So I'll leave some notes in here for you as well. Now that you have RStudio installed, are going to have a lot of stuff you're going to have to get compiled. So from this script, make sure you go down to the set environment. You need to set the time zone. I don't care what time zone you set it to. It just has to be set to something. The time zone is only going to impact the fact that what you're about to do is install some packages that aren't technically on CRAN or publicly released. And if you haven't figured out what a package is, or you haven't had experience with it before, a package is something that we bring into RStudio to allow us to do more features and functions. It expands, it's extensible. Imagine a package as a DLL. Once we install a package, we actually get all kinds of cool stuff we can do as far as functions that are included in these packages. If you were to go out and look at available, because this is going to be important, because this is what makes R amazing. R is nothing more than a language. It's the 11,000 packages that make R extremely powerful. So if you go to CRAN, which is the Comprehensive R network, this is where packages live. The first one that comes up is just going to be the list of packages. It's not that interesting. I don't get a whole lot of data out of that. If we go to CRAN contributed packages, we can see that currently the package repository has 10,926 packages. So we can take a list of these sorted by date, and you can see that there have been some opened, have been submitted today. Today's for me is June 26th, and you can see all these out here. You grab and pick the packages you need for the moment you need them. You don't ever probably want to install all 11,000 packages. There's no reason to it. No one on the planet is doing that many. These packages come from everything to stuff that we're going to be doing, like GGPlot, which is going to be plotting software, to things like, if you look at this, statistical depth functions for multivariate analysis, hazard models using state space models, climatology elements in R. There's a lot of amazing stuff that's put out here. So if you wanted to spend a boring afternoon, you could go look at all the packages that have been put out here. And these come from everywhere. The packages are put together from people like you and I who need, to solve a specific problem. We get tired of doing it longhand and we go create a package, to people that work at some of the top universities doing things like climate change and modeling it. So they create a package to help make it better for them to do, as well as a lot of data science algorithms. And actually this, just passing by, this is a package that will actually read data that's been come out of Minitab, SAS, SPSS, Stata, Weka, DBase, a wrapper for the API for the Danish Parliament. There's a lot of interesting stuff out here. And all of it is contributed. It's all open source. And as anything, when you pull down a package, if you're not familiar with it, please be careful. It won't do anything nefarious to your machine, but it could be kind of buggy if you're not familiar with it. So some of these are just put out here for fun. So you, since you have a new version of R installed on your machine and you have a new RStudio, are going to have to do, I have already done these, so I don't need to skip them. But first thing, if you're running on a server, you're going to have to start RStudio in administrative mode. So that would probably be the first thing you're going to have to do. If you're running on a Windows desktop, I can't answer. You may have to run this in administrative mode. The reason for that is we're going to have to install some stuff. As I showed you, the packages live on CRAN. So when I run these type packages, which I can install this one. So if I install dev packages, or dev tools, what it's going to do is go out and grab from CRAN a package called dev tools. Now, DevTools gives me the ability to do a lot of other stuff. You'll see very quickly down here, the very next thing I end up doing with it is install something from DevTools. So if we were to do DevTools, naturally there's no help. We can take care of that. So we come over here to help, and if you want to do it in Viewer, you can certainly do that inside the IDE. So it's actually going to come up with DevTools. Code tools, DevTools, build, blah, blah, blah. And you could also go run this, figure it out from CRAN if you wanted to as well, if you wanted to get more help. So we could do DevTools and just see what happens. In this case, we don't have to do, we do have to, for R. CRAN package DevTools. So just so you know, now there are huge, very tough standards for packages being put on the CRAN repository. This is one of them. When you create a package, you have to satisfy and answer all of the questions. The version, the dependency imports, all of this information. Who owns it? Where do your bug reports go in case you want to file it? And there also has to be a reference manual, which in this case, the DevTools PDF. And they all go by the same format. And then all the commands that are inside this. So every single package that's on CRAN has this type of information in it, as well as all of all of the commands. Remember I mentioned before a package is like a DLL. So these are all the things inside there that are available to you. We're going to use specific ones as we need them, but you need to get this one installed. The number you see to the right here is the one that I have installed. So get DevTools installed. You are going to need RCPP. That's actually a C compiler. And you're not going to need Lubridate, so you can comment that out and skip it for a later date. And then you're going to have to install, actually not dplyr, we're not going to be using it. You are going to need ODBC, GGPlot, and go ahead and install DBI, except we're not actually going to be using it today, but I think I'm maybe sending you some code in the future where you will be using DBI. So go ahead and get those installed. Like I said, make sure that, and the one thing I want to point out, one thing that you'll notice here, when we install the packages from CRAN, we do install.packages DevTools. So it goes out to the comprehensive R network and gets the package. When we go down here, we're typing in DevTools : install from GitHub. That literally means that we are going to GitHub to install a package called rstats-db/odbc. That is a piece of code that is, if you want to look at it this way, it's pre-production code. Even though I have a hard time ever saying that anything ever done in R is really production ready. It's kind of up to you to test it and make sure it doesn't fail, and then don't update anymore. Much like SQL. But we're actually going to be installing some stuff, and I needed these versions because they have some features and functions that have not been updated to the CRAN repository yet. These packages are all put under a greater umbrella of packages and software called the Tidyverse. Which we're only going to be picking and choosing. I completely misspelled that. We're going to be picking and choosing just a few of the packages that we want out of the Tidyverse. But if you go look, you'll actually see that these are all the packages that are in the Tidyverse. dplyr, forcats, ggplot, haven, lubridate, stringer, readxl, reader, per, and of course Tidyverse, which is kind of the master package. At some point in the future, this will be what we run, install packages Tidyverse, and then it will install all of these for us. But until I get to the point where I'm ready to do that, we're going to wait because I don't need all that stuff on my machine yet. And since we're literally using what I would still consider to be pre-production software, I just want exactly what we need and nothing more. So like I said, when you download it this way, these are going to compile once they get to your machine, unlike the ones in unlike the ones from CRAN, where they are already compiled. That's why you have to have RCPP installed, and that's why you have to be running in administrative mode. This is not going to put anything in your Windows directory. It's going to keep all the packages local. But ironically, this process can't call out to the compiler and make code unless it's running in administrative mode. Make sure when you run these that everything is successful. The only reason it wouldn't be successful is you may need to set your time zone, or you may need to make sure you're running in administrative mode. Then after that, you're going to want to run library DBI, because even though they're now installed on the machine, we have to make them available to the process, which basically it's like loading the DLL. So and this is nice. Gives us a hint, tells us try GGPlot mailing list. So if you want to get on their mailing list. So at this point, we should have all this good stuff installed. Hopefully you didn't have any errors going through there. If you did, contact me, or Google is your friend. So now we need to get to the meat of what we came here for. All right, so here we go. So we have a query. If we run it, the data looks like this. I'm not going to worry about, I'm not even sure I remember how to increase the output size. But this is what, I think I mentioned this earlier, this is what you provided, and I basically took out the aggregations. The point of this was to, for each interval, get the information for each interval for this function or stored procedure. What was the average CPU time? And you can kind of figure it out as we go through, that if it had a different plan ID, it'll show up twice for the same time interval. So this will be kind of useful. Sometimes when you're putting data together to get ready to go into a graph or a visualization, you kind of have to play around to figure out what is my data and which visualization is best for it. Plots don't do everything well. Histograms don't do everything well. Lines don't do everything well. You could actually dump it into Excel for a quick try and just see how it goes. But we'll get into that in a few minutes. First, we need to connect our R engine to our SQL server. So in this case, we're actually using the ODBC package. I've opted not to use the Microsoft package, and I'll show you why real quick, because people may ask you, or someone from Microsoft may even ask you. The problem is there are instructions. This is another file. There are instructions out there on how to get started with RevoScale R. The library, RODBC, if you go look for it, is actually somebody else's package. It's a package maintained out of the UK. There may be stuff in the future I use RODBC for, but since RStudio, the people, have recommended that I use the package ODBC, I'm going to be using that. So RODBC is another package by another person. RevoScale R has a database connectivity package as well. The problem is, watch what happens when I try and install RevoScale R on what is basically a fairly modern, released in April version of R. If I do the install packages, and I love autocomplete, make sure your quotes are there for this one. Do a RevoScale R, and let's run it. And we'll see that the package RevoScale R is not available for R version 3.4. Here's why that's a problem. The stuff we need to create the plots, we need to be in R version 3.4. RevoScale R has not done an update, I think, since October of 2016, which means they're 9 months behind now. So we can't use any of their tools to connect R to SQL Server, and I don't know when that's going to change. I can say anecdotally there have been some changes inside Microsoft, that what's left of that R team is now under a different team, and I don't know if we'll ever see anything from them again. So going forward, when it comes to connecting our engine and our studio to a SQL server, I'm going to focus predominantly on open source tools that are stable and well known. But I just wanted to point out, within the RevoScale R package, there are connectivity tools, but you have to be running about a 9-month-old version of our engine. And if you're doing that, none of the cool things you want are going to work. So we are going to be using ODBC for all the stuff that we're going to be doing for connectivity. Now, to get us started, this is, once you have this written, you'll never have to worry about it again. You just change it for what you need and move on with life. You do have to, you're going to create, and we'll just jump right into R and learn it as we go. So you can see that this basically is an ODBC driver. Literally, it's looking for the ODBC connectivity stuff that's on the machine. So, if you want to learn more about this and play around, there is a blog on RStudio, RViews, called RViews. Let's see if I can't get right straight to the blog. Database using RViews. So RViews is just the name of the site. Database using R. So if you go into here, this guy Edgar, he used to be I met him a couple of weeks ago. He's what I would consider to be a SQL Server user that now works for RStudio. So he is an advocate for SQL Server and other, but if you look at what they're using with ODBC, they're actually using the ODBC local to the machine. Hopefully they could use native client someday, but I'm not going to push it at this point. I just want to get something that's working. They do have a package called dplyr. I looked at it for about a day and decided it's not going to work. And not dplyr, but dbplyr. dbplyr gives you this really cool ability to write things like this table with the connection string and say query flights. The problem is it only queries the first 10 rows. That's not really useful for anything we can do, and you can't override it. So if you ever have a table that just has 10 rows in it, we have the package for you. I'm actually going to give them feedback when I've nailed down all the stuff I want to do with this and start publishing it and sending it to them so they understand that some of the stuff that they're working on with dbplyr, it's probably good for an introductory level 100 demo, but outside of that, it's a complete joke. So on the connection string, this is standard ODBC. If you don't have trusted connection in there, it will still work. You'll get back, and if this succeeds, as in it succeeds with no errors, that means your connection to the SQL Server succeeded. You are currently connected to the SQL Server on this information. Database from my port, blah, blah, blah. And if you're remote, obviously you just put the server name. If your machine is using user ID and password, use the standard UID and PID instead of trusted connection. But yeah, so the default is trusted connection, so even if you skip it, it's going to work. So for this one, let's get this out of the way. So this is the query that we had, that we were running in Management Studio. It should look pretty much like you saw it before. It removes the formatting when you paste it in. That's kind of annoying. So this actually is a different query. I want to show you. So in this case, this is kind of a bummer because we actually hard-coded the SP customer index source person 2 in here. And that's one of the stored procedures that happens to be in the CRN database. And actually, let's see here. I have a better one than this, SPSQL over time. You want to save this one? Yeah, sure, save it. So I have a better one I want to show you. It's the problem. I have multiple versions of this now. So this file is pretty much identical to the one you saw earlier. It's the part where we get down to past this. So I created a variable called SQL object. SQL object, now when we get into the markup, you'll understand what that means, or the markdown, you'll understand what that means. I want to pass in the object that I want to look at, which means that you could also do this in a loop and get lots of output. But for right now, I want to pass in the object I want to look at into a variable so I can change it easily. So I want to, and learning on the fly is the best way to go. SQL object is my variable. You'll notice it got put over here. It's just a character string. You'll notice that I loaded that up by using a less than sign with a dash, which means direct the whatever's on the right-hand side into the left-hand side. You can also use equal, but and you'll see both used and they're both correct. About 1 in 1,000 opportunities or times the equal sign won't work, but you'll probably never have to worry about that. So now I've got SQL object created. So the next thing I'm going to do, and this is going to look a little bit like Java, if you've ever looked at Java before, I'm using a thing called sprintf, or maybe even C. What sprintf is going to do is there's a %s down here. What that's going to do is it's going to say, when I run the sprintf, I pass in the s, and it's actually going to take whatever's after this quote, because you'll notice my quote string inside sprintf starts here and it goes all the way to here. I have a %s in here, and that is the escape character for there's going to be a string that you're going to find immediately after this first command ends, so this first function pass ends. Whatever you find in here, replace it here. So let's go ahead and run this. And the other thing too, it's really nice about SQL, and it's frustrated me for Management Studio. If you can highlight actually that won't work, because you'll notice down here, I want to show you what I did here in case you ever get tripped up. I didn't highlight that entire thing. You'll notice down here in the console window, it's waiting for more input. So you can start faking it out, or you can just put your mouse here and run it. It's kind of hard to get out of that mess. So we got a bunch of errors because I gave it an incomplete command. If your cursor is inside basically what would be considered this batch of stuff, because from here to here, R is well aware, this is one command. All the way to there. So R knows that's one command. So if my cursor is anywhere in the middle of that, all I have to do is hit run, and it'll run that thing. Now if you look over to the right, you'll see now that I have this SQL statement as a variable. Getting to look at it can be a little tricky, and I'm not sure this is the best way to do it, but it worked for me. So I'm actually going to do a view SQL statement, which is going to cause it to open up over here. So what we're looking for is, if you look down here at the bottom, the object ID, we're passing in the object ID of getString, and it'll figure out the rest. But the point is, we got the object into the string dynamically. That's what we're focused on. But that's what that sprint works. Sprintf works for. All right, so that's awesome. We have a query loaded up and ready to run. So now we're going to send the query to SQL Server. Here's our connection string, here's our statement, and basically we're going to give it rs, and that's going to be a pointer. So now we have db fetch, means that we got the data in memory. We want you to take that data that's in memory and put it into this thing called 1sphist. So run that. Now you'll look over here on the right, you'll see that we now have a data frame, is what this is called, because it shows up under data. And it has 333 observations with 10 variables. So you'll also notice with R, it's using the language of a statistician. So don't let that freak you out. A variable is the same thing as a column. An observation is the same thing as a row. Those are interchangeable. So don't worry too much about that. The other thing, it does this thing I don't like. You'll notice that we got exponential notation, which I find very frustrating. If you run this command called options scipin 999, it will actually change it. So if we go back here and look, actually let's reload this. Look again, our exponential notation will go away when we do the new view, and we can now look at the data that was passed in. Since it's only a few hundred rows, it's not that big of a deal. But if you want to go exploring, this is interactive, this view panel, so you can actually do some sorting, and it won't change the underlying object. I mean, you're just looking at this. It's kind of like Excel. Okay, so we got that DBC. We're going to clean up our connection for the moment just to be a good housekeeper. We'll go ahead and do the disconnect from the database because we're being a good housekeeper. We already ran the option scipin to get rid of exponential notation. This is just extra stuff if you want to look at it. So first thing we're going to do is we're going to jump down to one of the plots. We'll start with this plot right here because I need to talk a little bit about some stuff. GGPlot is the function that we're actually going to run. That's literally a plot. We're passing in the data frame, which is 1sp hist. This is called aesthetics, is what AES stands for. On the y-axis, we're saying I want to give it a logical I/O write. On the x-axis, I want it to give a date start time. So the minimum amount of information that we need to give this thing to get something back is this. So truthfully, we could actually, let me show you what happens if you run just this, just so you're aware. So if I run that off in the plot window, you'll see that I get a graph show up here, but I don't get any data. So that's kind of a bummer. With GGPlot, you also have to tell it to include the point. So now watch what happens. So now we got data. So on the x-axis we have the date and time, and on the y-axis we have the logical I/O writes. While that's all fine and dandy, I think we could probably squeeze a little more data out of that. Now, since the object we're looking at is the function, we're probably not going to have a lot of writes coming out of that function. They're probably always going to be a very small number. But let's get rid of this. Now, I'm going to change this up, so you can ignore this line for the moment. Jitter's kind of exciting. So the geometric point, we've actually, in the geometric point, we did another aesthetics. And I said, for the size, I want you to change the size of the point and make the size of the point the average duration divided by 1,000. Now the average duration is measured in microseconds, so I did a divide by 1,000 to get it down to milliseconds. And then I want you to change the color of the point, and every time you find a new plan ID, create a new color. Okay? So let's see what just this piece looks like by itself. See if I can stay in the console. We're not going to need the plus, so we'll highlight just that and see what we get. So this changes things quite a bit. Let's zoom out so you can actually get a better look at it. So now what we've done is we've added 2 more dimensions of information to the plot. So now we've got the duration in milliseconds, which that's all very low. So the size of the dot now directly correlates to how long it took to run. And now you wanted to figure out the plan ID. You could use the color to figure out. And what's interesting is you may see patterns. If we change this to the stored procedure, you'll actually see that the longest running stored procedures have a specific plan. I'm sorry, the ones that have the highest number of IOs have a specific plan, whereas the ones that have the lowest IO also use a specific plan. So you can start to see patterns in the madness. But we'll get into that one in a second, because right now, as we're playing with this, I also want to, and we can put the labels on here too. So if you do the title on the labels, that's what I want to show very quickly, is the title is the main title. Let me go ahead and show you what this looks like. The title is the main title, and then you get into the x-axis is the month of day. You get into the y-axis, we change it to logical I/O writes. And it's up to you to modify these. So if you change the variable on the y-axis and don't change it here, your plot's going to be wrong. And that's really annoying. Color, so it knows there's a color legend. So all you have to do is just say, what's the plan? What do you want the color legend name to be? Which is plan, and then the /n is just a return character. That's to force a return. And then size legend is going to be the duration in milliseconds here. So that's what that was for. But you can see this adds, this is mostly kind of eye candy to make it just a little bit better. There's one more thing I want to show you. In this actually we have to get to a smaller data set. So we're going to back up one. Let me get back to where this was, since I completely gutted this one. Okay. The jitter we're going to show you, I'm going to show you what the jitter does next. Alright, so first things first, we're going to create a small data set called SML. To do basically a where clause and save it to, a new data frame, which that would be the functional equivalent of, create a tiny table for me in SQL. You do a subset, you give the data frame that you want the subset of, and you literally type in what field do you want to look at and what values do you want it to be, above or below or equal to. So we're going to create something called SML, and let's put this back to where it was. And let's get rid of this. And now we have this thing out here called SML with only 34. But I told this to go find a start time that has less than 6, where the dates are less than 6/4. So if we open this up, we'll see we can get more granular data. We can see that we had 2 observations on June 1st, and we had 15 or so on June 2nd. And it was 1 observation per interval per plant ID. So obviously, like this one, we captured ran 2 plant IDs on 6/2 at 1 o'clock, and same here. So this gives us a smaller data set to look at, because what I want to show you is what happens when you do this. So in this case, the understanding the plot, we're using SML. We're doing the logical I/O reads. We have geometric jitter, and I'm going to show you why it's important in a second. And I want to add a, let's see, title. So if we do that, we'll get kind of what we saw before. Let's blow this up. Bigger. So now what we're going to get is, on June 1st, it was run twice. It ran 2 different plans, plan IDs. And on June 2nd, it ran. And on June 3rd, it ran. Okay, so that's kind of interesting. So one of the things we can do is to try and figure out, just to make sure you understand the plot and what you're displaying, because it is easy for you to get into a situation where you look at a plot and don't fully understand what you're looking at, is we have the ability to add text. So we can say, I want you to label this. And actually, in this case, I didn't want it to label everything. So I said, if the logical I/O reads are greater than the standard deviation of the logical I/O reads, to display it. The point of doing that was to try and limit how much data we got on this. But as you can see, that didn't really work. No, I'm not going to worry about it right now. But what I wanted to do was label the dot. So if you wanted to go back and look at it, you could see where the dot fell on that day. So on June 1st, we knew we had 2 the same day, 2330 and 2330. They're in different points because they had different logical I/Os, and they actually had different plans as well. But these 2 ran in the same time interval. It was run twice. But this gives you the ability to try and figure out, where is my data exactly, even though it doesn't look very friendly. So jitter. Let's comment out the text real quick. So let's make sure you know what that looks like without the text. All right, so we're going to run this. So we're back to where we were. We have 3 rows of plots, basically on July 1st, on July 2nd, and July 3rd, and where they fell. So now I want to add jitter, because you'll notice that some of these dots are kind of overlapping each other a little bit. That can be kind of annoying depending on what you're trying to figure out. So jitter there's this thing called jitter in the plot community, where basically it says, I want you to take a dot that's overlapping another dot and offset one of them by just a tiny bit. Okay? Here's what happens. I'm not going to say whether this was good or bad. I'm just going to say this is what happens. It moved the dots all over the place. Now, we only ever had the data show up on the 1st or 2nd, but now it's been moved. Let's see what happens when we put the text back. I'm pretty sure this is going to break it. So, yeah, the problem is the data, the dots are jittered. The text is not jittered. So you get into this weird problem. Let's close that, because it upsets me just to look at it. But what I want to show you is I am using jitter throughout, and I'm going to show you how to do both with and without. And you need to decide, is this good or bad if you do the jitter. Actually, let's get rid of this. Learning as we go. Yeah. So when I take that out, the ones that got jittered actually did not get and that's the other frustrating part. And I do need to look into this. The ones that are not jittered, basically, the ones that got moved, they lost their color and they lost their size. That's why I actually had this in here twice. But I'm going to work on this for jitter and kind of get back to you when I have a better solution to this. Probably the safest thing to do right now is shrink the time interval and then just don't use jitter. Because if you've got so much information, it's like everything else, that you can't detect it or differentiate it, you've probably got too much data on the screen. So that was kind of what that was for. And this was SML. This was just 3 days. But this shows you how, if you just want to get a smaller time frame, this is how you would go about doing it and then passing it in. So let's go through the rest of these real quick. This one is, let's see. This is logical I/O writes for that same function. That's kind of awesome. So we come down here and we do max memory. So this is with jitter off. So we do the average. Oh, this is average CPU time, month and day. So you can actually get that some of these are running kind of fun. So, okay, so this is really cool, but this still doesn't solve the problem in the fact that I can now do all this awesome stuff in our studio. How do I get this in a format that I can share it with somebody else? Or what if I want to print it to a PDF? In this format, it's only marginally better than SQL Server spitting it out to a temp directory, which quite frankly, it can't do a very good job doing this anyway. So what do we do? So R has this thing. They actually have two things. One of them is called a notebook. This version of RStudio introduced the R notebook, so this is brand new. I'm not a huge fan of notebooks because you kind of have to have the SQL Server laying around that you're connected to. Now, what it also has is R Markdown. R Markdown is actually, we'll go ahead and create a demo one just so you can see what it looks like. So R Markdown is an HTML-like interface that has our code built into the middle of it, so you can actually describe it. So when you open R Markdown for a new project, it basically will let you. We're going to go and do demo. Yes. What it'll do is give you this thing to go ahead and run, just so you can kind of see what it looks like. So R Markdown document. The first thing it does is there's a code block here that says do a summary on something called cars, which there is something in the built into our engine called cars. So if we were to go back to, let's open a new window real quick. New R script. So if we do just cars, what happens? We actually get, ooh, that was kind of fun. Let's do view cars. Let's look at it kind of in a pretty format. So we didn't have to install any packages or anything. It was just already there. So we do a view cars, we actually see speed and distance. So this is the speed of the vehicle and the stopping distance at that speed. That's all that is. But just so you understand what cars is. It's a package it's a data set that's available without actually having to load it. It's already there. So that's what that was. That was an R script. And if you look down here, you'll see they ran summary. And it's inside this R code block, summary cars. Cool. And then it says you can also embed plots. So you can see that we close that, and then we go back to text, and then we go back to plot the pressure. Pressure is not part of cars. It's something completely separate. But if you look at this, we'll also see that you can split a plot out. In case you're wondering, this is what a base R plot looks like. That's why we're not using base R plots, because GGPlots are far prettier. So cool. All right. So can we put all the stuff that we've done into that little R Markdown, which sounds like really, really awesome. Ooh, can't find that one. So where did I put it? Recent files. This is what I get for cleaning up in the middle of in the middle. This looks like stuff. All right, so here we go. What we have in the R Markdown, we can close this up just a tiny bit. So in the beginning, we have the title. That's going to show up at the top, and then we have the knitter. You can pretty much ignore all the stuff that's in the top up here. It's not important to the stuff that we work on. I will, in some point, probably send you some markdowns eventually that may have some extra stuff up here. Or if you start getting into writing your own CSS style sheets, it'll all go in this little section right here. What we're interested in is getting into the meat of this, which means that we need to get into an R block. Now, you do have to run this before every compile, but you also have to run it before you run ggplot. I've actually had an issue. I think it's with the ODBC connection. I actually had to run it before. So what's going to happen is when we run this entire sheet is going to run. Now, these packages for ODBC and GGPlot need to have already been installed on your machine. That's why we're not doing an install package. If you ship the R Markdown to somebody and they do not have the ODBC package and the GGPlot package already installed, and it's not the version that we're using, this will fail. And eventually you'll see what this looks like if you change some stuff. But basically, this is the same code that we were looking at in the R script I was showing you. And we're going to, just for fun, we're going to shake things up a little bit, and we're going to look at the other, we're going to look at a stored procedure. So all you have to do is change this name to something else if you want to demo it, and that will basically change the proc to something else. I am going to do a shiny version of this, which will be an HTML interface, where ideally you can do imagine a web page that has a drop down of the 10 highest or 10 highest consuming resources on the machine, and then we'll just dynamically build out the page. But that's going to take some time to do. And that's going to be my next step, probably for this very one. You'll see that we have the connection just like we had before. We have the query just like we had before. You'll notice that we have the SQL object, which we loaded up. And we have, basically create the data frame, clear the results, set our exponential notation to basically off, and now we're going to start running all of the plots that we had in here. I am, for this purpose, going to comment out jitter on these and let you decide how you want to handle it. Jitter can be, as you can see, it can skew your results pretty significantly. So it might be something that you talk about with people, or if they ask if there's overlaps, this is how you handle it. And then basically be prepared for bad data. It's kind of, or not maybe really bad data, but nefarious data. So we have this thing ready to go. So what do we do? Click knit. And what that's going to do is that's short for knit to HTML. So it's actually going to open a, and you can monitor progress down here at the bottom. If it's not successful, you'll see a giant execution halted in the R Markdown section. But it goes through each one of these blocks and tells you. But if something goes wrong, you'll get a big gnarly message at the bottom and you won't be able to miss it. So for the stored procedure, we actually get the same thing we did for the function, except now we have it in one document that we can look at. With all this nice stuff. So you can get plan ID, logical I/O, month of the day, the size, and don't forget this is milliseconds because I divided by 1,000 from microseconds, and stored procedure write over time, CPU over time, and this is going from June 6th to June 14th. And you can see at the bottom that what I was talking about with jitter, this would have solved, jitter would have solved these, the dots being overlapping each other. But the problem with jitter is it can cause some weird skew. So for the memory one, it was where it was worst. And actually I can put that back just so you see what jitter looks like with and without. So by doing that way, just so you can get an idea of side by side of how goofy it is. For this particular stored procedure, I don't think it's going to matter. Yeah, max server memory. But yeah, a little bit. Okay, so it did do that. So you can see when it did the jitter, it actually decided to drop them below the 0 line, which basically makes this look like a lie. Because now the graph doesn't represent the data, which is a hugely bad problem. So hopefully all of this has worked for you. If it hasn't, please let me know. This is kind of get you started and to get stuff running. You might have enough to where you can start adding more stuff. I'm going to try and figure out a way to extend this to HTML via an app called, or via an extension called Shiny that will hopefully give us the ability that you can open up a page, it will go query the data, get the top 10 most consuming resources, and then you can literally dynamically change this with whatever you want, whenever you want. So that would kind of extend the query store to be something that's like a dynamic web page, basically. Anyway, hopefully some of this was helpful. I know it's a lot of information.